In this video, I want to cover U substitution, and the first problem we're going to cover is the integral of x squared sine of x cubed dx. Sometimes you can't integrate right away, and you have to change the integral to make it easier to integrate. What you're going to want to do is replace all the x variables with u variables, and the first step is to pick your u variable. And the way you want to pick it is you want the derivative to be the rest of the function that u is not. So say we picked u to equal x cubed, we would want the derivative of this to be able to be x squared, right? Because then all our x terms would be in u terms. So if we said du, which is the derivative of u, is equal to 3x squared dx, and if we divided by 3 on both sides, we would have 1/3 du is equal to x squared dx. And if we look at u is x cubed, which takes care of this x term, and 1/3 du is equal to x squared dx, which takes care of x squared and dx. From this point, we can see that all our x terms are able to be replaced with u terms. So the next step that we would need to do is to actually substitute in those u terms. So by rewriting this integral, we're going to say the integral of sine of u, because u is x cubed, so we're just replacing x cubed up here. So sine of u times 1/3 du, because 1/3 du is equal to x squared dx, x squared right here and dx right here. So this right here is the exact same thing as this up here, except this integral is now in terms of u. So the first thing we can do is, we see this 1/3, we can just pull it out to the front. So we're going to say that this is 1/3 times the integral of sine of u times du. Well, we know the integral of sine is negative cosine, so we can just say 1/3 negative 1/3 cosine of u plus c. And the very last step is to replace the u variable right here with what it was when it was x. So if we look up here to our u variable, x cubed was our x term. So the answer to this integral is negative 1/3 cosine of x cubed plus c. And that is the answer to this problem. So for our next U substitution problem, we are going to take the integral of 3x squared times x cubed plus 5 to the 7th dx. So the first thing we want to do is we want to find a u so that when we take the derivative, it takes care of the rest of the equation, or the rest of the function that wasn't taken care of by u. So say we said u was 3x squared. If we took the derivative, that would be 6x. 6x does not take care of the rest of the problem, right? But what happens if we said u was x cubed plus 5? So if we said u is equal to x cubed plus 5, the derivative of u is equal to 3x squared dx. So if we check this function to see if u's have taken care of all of the x's, well, we can do that right now. So x cubed plus 5, or x cubed plus 5 is u, and we have this part of the equation taken care of. Now we just need 3x squared and dx. Well, what do you know? du is equal to 3x squared dx. So now that we know that u's, we have all the u's necessary to replace our x's. We now just need to substitute them in. So we're going to take the integral of u to the 7th, because this is where u is taking care of that, times du. And now these two equations are the exact same. One's just in terms of u and one's in terms of x. So this is a very simple actually problem to integrate. All we do from here is just add 1 to 7 and then divide by the new exponent. So this would be equal to u to the 8th divided by 8 plus c. But if you remember, once we're done, we have to replace u with what x was to get it back in terms of x. So if we look back up here to u is x cubed plus 5. So we need to replace u with x cubed plus 5. So if we write x cubed plus 5, can't forget to raise it to the 8th power, divided by 8 plus c is the answer to this U substitution problem. So for problem number 3, we're going to take the integral of 4x times x squared plus 5 cubed dx. So just like the other problems, we need to figure out what the u variable is going to be. And usually the u variable is the biggest section of the problem. So if we just look at the biggest section and we took the derivative of what was in here, we would see that it would just be 2x, right? 2x dx. Well, that takes care of the x and the dx, and we can manipulate the constant to make it take care of the 4. So if we set u equal to x squared plus 5, and then we took the derivative of u is equal to 2x dx, we see that u takes care of this right here, and du takes care of the x and dx. We now need to divide this side of the equation right here so that we can make 2 actually be equal to 4. And I see that we can divide 2 by 1/2, and that would be equal to 4. So if we divide by 1/2, and then we divide du by 1/2, if we multiply by the reciprocal, we will get 2 du is equal to 4x dx. Now 2 du is equal to 4x dx, 4x and dx. We now have this entire problem in terms of u. Now we just need to substitute them in. So if we take the integral of, first we put in u, so u cubed times, we need 2 du. Now this whole entire problem is now in terms of u. This integral and this integral are now the exact same thing, but one's in terms of x and one's in terms of u. Since this is a constant, we can bring it out to the front, so this is equal to 2 times the integral of u cubed times du. Now we can integrate u cubed, and that will be equal to u to the 4th divided by 4 plus c, and then we can't forget the 2 is a constant, so we multiply 2 by this answer, and we'll get 2u to the 4th divided by 4 plus c. But if you remember, we want to get this back in terms of x, because the original problem was asking we need to differentiate in terms of x, right? So if we set this equal to 2/4 times u is, if we look up here, u is x squared plus 5, so x squared plus 5. Can't forget the power of 4 plus c. This is the answer. We can actually simplify this further. 2 over 4 is 1/2, so this will be 1/2 x squared plus 5 to the power of 4 plus c. And this is the answer to this problem. So for our next U substitution problem, we're going to have the integral of x cubed divided by the square root of 1 minus x to the fourth dx. So looking at this first, this is a little bit different than anything we've done so far, but the principles are the same. We find the most complicated part of the problem, and then we can just try that as our u, right? Because that's generally the case. The most complicated part of the problem, say if it's like within inside of a sine function or within some kind of square root or on the denominator, that's usually a good sign that that's u. But I mean, if it's not, we can always try something else, but it's typically a good thing to try that first. So if we were to say u is equal to 1 minus x to the fourth, so u is equal to 1 minus x to the fourth, the derivative of u is just negative 4x cubed dx. Yeah, okay. So if we look to see if u's take care of all the x's, so u is equal to 1 minus x to the fourth, and we have this right here. Now we need, what we need last now to get taken care of is x cubed and dx. So we have that here, x cubed and dx, but we have a pesky little 4 in the way, right? So what we can do to get rid of it is just divide by 4. Divide by negative 4, actually. So this would be negative 1/4 du is equal to x cubed dx. Now if we look, u is equal to 1 minus x to the fourth, which is right here. So those x's are taken care of. And negative 1/4 du is equal to x cubed dx. So we have all our u's that we need to replace our x's. What we now need to do is substitute it in. So we're going to have the integral of 1 divided by the square root of u times negative 1/4 du. So that takes care of everything. We can actually rewrite the square root of u as u to the 1/2, and then we can move u to the numerator by switching the signs of the exponent. So we can say u to the negative 1/2, and that would just be the same thing. So if we took the integral of u to the negative 1/2 times negative 1/4 du, we can now try to integrate. So what we're going to do here is we're going to take this constant and move it out to the front. So we're going to have negative 1/4 times the integral of u to the negative 1/2 times du. Okay, so now we can integrate. We can add 1 to negative 1/2, which is 1/2. So we're going to have u to the 1/2 divided by 1/2. Can't forget it's multiplied by negative 1/4 and plus c. And then we can take care of this fraction on the bottom by multiplying by the reciprocal, which the reciprocal of 1/2 is 2/1. So this is going to be equal to negative 1/4 times 2u to the 1/2 plus c. Okay, so we can take care of the negative 1/4 and 2, and that's going to be equal to negative 2/4 times u to the 1/2 plus c. And then we can substitute what x was for u. So we find u, and it was 1 minus x to the fourth. So this is going to be equal to negative 1/2. All I did was simplify the 2/4 times 1 minus x to the fourth to the 1/2 plus c. And that is the answer to this problem right here. Right here, yeah. We can actually further simplify this. As you can see, 1/2 is the same thing as the square root, and since this whole thing right here is to the power of 1/2, we can just further simplify this to negative 1/2 times the square root of 1 minus x to the 4th plus c. And that is the most simplified version of this problem. So for our fifth problem, we're going to take the integral of 8 cosine of 4x dx. And like I said before, usually you're going to find your u in the most complicated portion of the function. And if you have like a trig function like cosine, sine, tangent, something like that, it's typically going to be the angle of the function. So in this case, it's typically going to be 4x. And we can try it out. And if it's not, we can always try something else. But it's usually a good idea to build your intuition on where you can start like trying first. So if we set u equal to 4x and du is equal to 4 dx, we see that if we check to see what's taken care of, we only have two x's, right? Dx and 4x. So u is 4x, that's taken care of, and 4 dx, well, 8 isn't taken care of, but dx is, and we know that we can manipulate the constant on the right-hand side by dividing it by something else. So I know that if we divide 4 by 1/2, we get 8. So we have to divide by 1/2 on both sides. And this will leave us with, because we have to multiply by the reciprocal if we divide by a fraction. So this will end up being 2 du is equal to 8 dx. And now if we look, 2 du is 8 dx, and then u is 4x right here. So everything is taken care of. All we need to do now is substitute it in. So if we have the integral of cosine of u times 2 du, these now are both the same integral, but this one is in terms of x and then this one is in terms of u. And it's also much simpler. We know that the antiderivative of cosine is, well, before we even do that, we can move this constant out to the front. So this is going to be equal to 2 times the integral of cosine of u times du. And now we're ready to take the antiderivative. So the antiderivative of cosine is sine. So this is going to be 2 times sine of u plus c. And then all we do is replace u with what x was. So u up here, if you look, is 4x. So this is 2 times the sine of 4x plus c. And that is the answer to this problem. For our sixth U sub problem, we're going to take the integral of x cubed times e to the x to the 4th dx. And the way we're going to do this is just like any other time. We need to find u. And I can see that, I know that the derivative, when I take the derivative of something, the exponent is subtracted by 1. Here's a 4. If I subtract 1 from 4, I get 3, right? So I'm thinking that the u could be x to the 4th, because when I take the derivative, it would be 4x cubed, and it'll take care of this and dx. And I can just have e to the u. So let me try that real quick. So if I say u is equal to x to the 4th, and du is equal to 4x cubed dx, I can see that u is x to the 4th, which takes care of this part of e right here, and du is equal to 4x cubed dx. Well, x cubed dx takes care of this right here. So everything is taken care of. I just need to divide by 4 to get rid of it. Divide by 4, so 1/4 du is equal to x cubed dx. And now this looks like I can substitute everything in properly. So, or I can substitute all the u's in for x. So if we take the integral and we say e to the u times 1/4 du. These are now the same integral, right? Same integral, except now the bottom is in terms of u and is much simpler, and the top is in terms of x and would be incredibly difficult to integrate. So if we were to move the constant out to the front, this would be equal to 1/4 times the integral of e to the u times du. And if you didn't already know, this is pretty cool. The antiderivative of e to the u is e to the u. So this is going to be 1/4 times e to the u plus c. And all we have to do is get this answer down here back in terms of x. So u, if we look up here, is x to the 4th. We can now rewrite this answer as 1/4 e to the x to the 4th plus c, and that is it. That is the answer to this problem. So our 7th problem is going to get a little bit more difficult, even though it doesn't look like it's going to be at first. So we're going to take the integral of x times the square root of x plus 2 dx. So in finding our u, just like anything else, any other problem, we look for the most complicated part of the function, and it seems to be this right here, what's inside of the square root, so x plus 2. That seems to be a good choice. So u is equal to x plus 2, and then du would be equal to dx, because the derivative of x plus 2 is just 1, because x to the first power, you take down a 1, so 1 times x to the 0th power is 1 times 1, and then 2 just goes away. Okay, so if we look at this right here and we try to see if we can substitute in our u's to replace all the x's, u is equal to x plus 2, which takes care of what's inside of this square root function. And then du is equal to dx, which takes care of this. But we still have an x here. What we can do is, if you see here we have x plus 2, if we subtract 2 from here and have u minus 2, that would be equal to x. So if we say u minus 2 is equal to x, if we look, u minus 2 is equal to x, which takes care of this right here. Du is equal to dx, which takes care of dx. And then u is equal to x plus 2, which takes care of what's inside of the square root function. So now we have all the u's necessary to substitute in for our new integral. We're going to say the integral of, so x is u minus 2, so u minus 2, and then times the square root of x plus 2 is now u, so times the square root of u, times, and then we need to take care of dx, which is du, times du. And now this is our new function. These both are the same thing, except the bottom is now in terms of u. To make this easier, we should take the square root of u and write it as u to the 1/2 to make everything just easier. So we're going to say u minus 2 times u to the 1/2 times du. And then what we're going to want to do is we're going to want to distribute. We're going to multiply u by u to the 1/2 and negative 2 times u to the 1/2. So that's going to be equal to the integral of u times u to the 1/2. That's u times u to the 1/2. If you knew the index rules, all you have to do this is 1 plus 2, which 1 plus 1/2, because this is 1/2. 1 is the same thing as 2 over 2, so this is going to be equal to 2 over 2 plus 1/2, which is equal to 3/2. So we are going to have the integral of u to the 3/2 minus 2u to the 1/2. times du. Okay. Now we can get into integrating. U to the 3/2 plus 1 is the same as U to the 3/2 plus 2 over 2. So that's going to be equal to U to the 5/2 divided by 5/2 minus 2 1/2 plus 1 is the same as 1/2 plus 2 over 2, which is 3/2. So we are going to say minus 2U to the 3/2 divided by 3/2 plus C. Okay. So now we need to multiply by the reciprocals just to clean this up. If we divide by a fraction, we need to multiply by the reciprocal. So the reciprocal of 5/2 is 2/5. So we are now going to get down to 2U to the 5/2 divided by 5 minus the reciprocal of 3/2 is 2/3. So we're going to be left with 4, because when I multiply by the reciprocal, we have to do 2 times 2. So 4U to the 3/2 divided by 3 plus C. And that's it, except now what we need to do is we need to replace all the U's with X's and get this new answer in terms of X. So if we look up here, X is equal to X plus 2. So this is going to be equal to 2/5 times X plus 2 to the 5/2 minus 4/3 times X plus 2 to the 3/2 plus C. And this is going to be the answer to problem number 7. So for our next U substitution problem, we are going to take the integral of tangent x dx. Okay? And tangent x is the same thing as sine over cosine, so we can rewrite this as the integral of sine of x over cosine of x dx. And then we can use U substitution. I know that the derivative of cosine is negative sine, so we can use U as we can use cosine as our U, and then du can be negative sine x, we need to put x, dx. And we're trying to replace sine, so we need to divide by -1 to get rid of that negative. So divide by -1. We're going to be left with negative du is equal to sine of x dx. Okay, so if we look, u is equal to cosine, that takes care of this, and negative du is equal to sine x dx, which takes care of this right here. So far so good. We can rewrite this as this integral as the integral of 1 divided by u times negative du. And if we look, these are the exact same thing. We can then try to write u. We need to take care of this constant of -1, so we need to -1 times the integral of 1 divided by u times du. We need to write u from the denominator to the numerator, so that's going to be equal to -1 times the integral of u to the -1 times du. Now we can try to integrate. We need to add 1 to the top and then divide by the new exponent. So this is going to be equal to -1 times u to the 0 divided by 0 plus c. And it seems we've run into a problem. We cannot divide by 0. So what we're going to have to do is we're going to have to approach this integration differently. And if you didn't know, the integral of 1 over u is the natural log of u. So this is going to be negative ln of u plus c, the absolute value of u, because we run into a divide by zero problem. So you just have to remember that the antiderivative of 1 divided by x is the ln of the absolute value of x. Okay. So this is the now we need to replace u with what x was, and if we look to see what u is, it's cosine of x. So this is going to be equal to the negative natural logarithm of the absolute value of cosine of x plus c. And a property of natural logs, it allows you to take the coefficient and move it inside of the natural logarithm as a power. So the coefficient can move to the power. So this is going to be equal to the natural log of the absolute value of cosine of x to the negative 1 plus c. And then cosine of x to the negative 1 is the same thing as 1 over cosine of x, because if we switch the signs, it brings it down to the denominator. So this is going to be equal to the natural logarithm of the absolute value of 1 divided by cosine of x plus c. And if you didn't already know, 1 divided by cosine x is the same thing as secant. So this is actually equal to the natural logarithm of the absolute value of secant x plus c. And this is your answer.